Hey, what's up? So it has been a year since my last video, and more than that since my last devlog, which was just in its beginnings. Well, I have not abandoned the project. In a way or another, I was working on it every day, or at least thinking about it every day. I still have the same dreams, making a game studio, and maybe make a game like Elden Ring someday. But life is hard, and game dev is also hard. So what I did, I made it even harder. I am making a game engine.
No, 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 no! Wait!
Why I'm making a game engine? Well, that is a topic on its own. And to be honest, I'm not sure what I want to say in this video. Should I talk about what I have been doing the past year? Should I talk about the engine or the game? Or should I talk about my mental health issues? I guess it is better to start from the beginning and see how it will go. I'm being honest here, I'm not preparing any scripts. I'm just here to make a video to first inform you I'm still alive, and secondly that I'm still working on, well, my stuff. The whole story really starts from the fact I love games. I guess they are the best way to experience a tale or a story in a unique artistic way. And I want to make them, make great games and sell them, and then make more great games and sell them and so on. I had many attempts to make and ship my first game, but I just couldn't due many reasons. School, not having a good PC, motivation. But as I said in my first devlog video, the main reason is art, because when I reached the point of having anything good looking, I gave up before trying. In 2023 I opened Unity, the engine I have been using for more than 8 years at the time, and start making the game once again regardless of my ability to make art. I wanted to defer that problem later and not think about it until I have something solid. So I made the first devlog, the second devlog, and I was on my way making the third. And we all know what happened. Suddenly, out of nowhere, Unity made the dumbest move a company can make, the runtime fee. I was furious because I was relying on that Plus subscription plan to remove their stupid splash screen. And they removed that subscription plan. Also, that runtime fee was the most idiotic thing I have ever seen in my life, even if it did not affect me at the time because, I still haven't shipped any game yet. But just the fact that they can pull something like that from nowhere anytime was a deal breaker for me. I even made a video saying I'm done using Unity. And after a day or so I removed that video because, to be honest, I was kinda driven with emotions instead of reason. And it was a rush thing to claim. The reasonable action was to wait and see how things will go. So that's what I did. But despite whether Unity was going to roll back their stupid runtime fee or not, and eventually they did, you can even disable the splash screen for free now. But despite that, it was clear for me I need to start considering other options. Other options like learning new engine or making my own, because that idea of making my own engine has been whispering in my ears for quite some time back then. But I wanted to try Godot and Unreal first. That was not the first time I used Unreal, by the way, but nothing deep or major. My experience for both engines were kinda weird. At first, I liked the simple Godot user interface so much. It was so clean and compact. But after some time, I could not look at it the same way, unlike Unreal, which was really good for me to work with. But I gotta admit, maybe that's just because I'm used to Unity's user interface, and that is why I found Godot a bit weird, because it is new for me. But still, I don't like Unity's UI that much, so I don't know. Anyway, Unreal was the closest thing I could work with. But goddammit, it is so heavy that I need to wait an eternity for it to open, even for an empty project, just like Unity. And I like coding in C++. In fact, it is more of a requirement than a preference if you want to make good games with respectable performance in Unreal. But in Unreal, you need to wait an unpleasant amount of time after each code change. And despite my age is 24, I'm getting old. And waiting for something to do something is gradually moving up the list of things I hate most in life. Godot is fast, I will give it that, but I could not force myself to work with it for many reasons. Mainly because of the editor. Or mainly because I'm stupid, I'm not sure which one of those is the real answer. But you know what? In reality, all of those things I was just talking about are just excuses for me to make my own engine. Because those engines are not bad. It is quite the opposite. Great games have been made with those engines, and I will be using an engine in the future. It is not the end of the world to work with Unity. In fact, in my current situation, it will be the smarter thing to do. Of course, I will still have to deal with this mother popping at my face every time I try to do something, but at the end of the day, it is not something that you cannot live with. If I want to be completely honest with you, I want to make a game using a custom game engine just because I want to. There is no other reason. That's it. But if you really want some reasons, it all comes down to one actually. I want to try it so I don't regret not trying it later. If it is something I cannot do, I will just use an engine. But even then, it will be worth it because I would have learned a lot of things that will help me when using Unity or Unreal or any other engine. And spoiler alert, I guess it is true. I feel like I am a better programmer since last year by a magnitude. One of the most important things I wanted to learn for a long time is shaders and rendering. You can take your game to a whole nother level if you master shaders. Not just in terms of visuals and art direction, but even in performance. And yeah, you can learn them directly in Unreal or Unity, but I personally could not until I started making my engine this past year. In general, I wanted to know how big games are made, so I can somehow bulletproof myself in the future if I have given the opportunity to make that one big game with a team and everything. Another possible reason is that I wanted to limit myself, if so to speak. Somehow, I feel like I'm not going to make a game just because my stupid scope ambition. If I have a limited tech, I will be forced to think outside the box, to make something amazing and creative, but within my reach as one-man solo developer. This, however, does not mean I'm intending to make a weak engine or something. In fact, I ended up implementing some really advanced stuff that I'm really proud of, and I guess it will pay off eventually. Anyway, so I guess enough of giving random reasons why I started making a custom game engine to make my game. As I said, the only real answer is I wanted to, and yeah, that's it. You know, to feed my ego or something. But don't worry, my ego will soon be crushed and I will be forced to use Unity or something. And I'm okay with that. I'm just letting you know, I'm fine with that. It will still be worth it, nonetheless. So in early October last year, I started learning Vulkan. For those who do not know, Vulkan is basically a graphics API. Its job is to send commands to the GPU, and therefore you can use the GPU to do anything you want. There is also DirectX 12 for Windows and Metal for macOS and iOS. Vulkan is kinda cross-platform, so it can run on pretty much anything you can think of. But not everything. Consoles do not support Vulkan, except for the Nintendo Switch, I guess. This was not the first time I tried to learn Vulkan. I tried to learn this before, but I just gave up before even drawing the triangle, because it was just a lot of code and none that I can understand. Of course, this time I had to learn it, so I spent I guess almost a week writing code. Sometimes I understand what I'm writing, and sometimes I just give up and copy-paste whatever in front of me. And after a week or so, I rendered my first ever triangle using Vulkan with almost 1000 lines of code. So yay. After rendering that triangle, I continued the tutorial, adding buffers, uniforms, textures, and I'm not going to lie, most of the time I was just doing Ctrl-C and Ctrl-V. I had no idea what the hell I was doing. But you know, once something works, I delete everything and try doing it from scratch in order to understand it. Vulkan tutorial, the website I'm using for learning Vulkan, is good, but to be honest, it is not the most ideal place you can start learning Vulkan for making a game engine or a framework in mind. It is kinda one-dimensional to the point where the code in the tutorial is so specific to the tutorial. There is no abstraction in mind in any shape or form. And because of that, once I completed the tutorial, I started another one named Vulkan Guide, and that one is so good for my use case. Because the tutorial is made in a more abstracted way. I'm not saying Vulkan tutorial is bad. In fact, it is super good for understanding Vulkan initialization and some low-level stuff. And to be honest, I'm not sure I would have understood the Vulkan guide in the same way I did if I did not start with the Vulkan tutorial first, so keep that in mind. After finishing the Vulkan guide, I felt I had become a bit better with the API. I could do something with it. But the majority of what I learned still felt blurry and I had more questions than answers. One thing that helped me a lot in understanding Vulkan better was the sample projects by Sasha Williams. Those samples are absolute gems for anyone trying to learn how the API works. They aren't something you would simply copy and paste into an engine or a framework, as they are very specific to the topic of each sample. And that's exactly how it should be. I learned a lot from those samples, they are simply amazing. After about 2 months of this, I had to shift my focus to school projects, or I will be kicked out from it. So I spent another month or so working on a mini shell, if you will, along with other school projects. My school is entirely project based, so making and submitting projects is how you can stay there. Once I finished some school projects, just enough to keep me from being kicked out, I returned to working on whatever I was working on. But I stopped for a while and didn't touch Vulkan or anything else. I was just thinking if I really wanted to do this. It seems like a lot of work and I wasn't even sure I understood Vulkan very well, let alone making an engine with it. I was confident I could, but I was also sure it would take me an eternity to write a robust production-ready abstraction renderer for Vulkan. And we are not even talking about graphics yet. Things like projections, materials, shadows, lighting, and many other features. No, we are just talking about setting up the very low-level components of Vulkan. Only after that could you even start thinking about making graphics. And even then, you'd only have Vulkan. If you wanted to target other platforms like Xbox for example, you'd need to implement DirectX 12 as well. So I realized I needed a framework to abstract the low-level details for me so I could focus on making the actual graphics. I spent so much time searching for such a framework and was very close to giving up. Then by accident while scrolling through YouTube, I saw a video from Game From Scratch talking about the Forge framework. I like the idea that it provides an abstraction for multiple graphics APIs while still giving full control over how you want to handle rendering. It was exactly what I needed, so I started learning how to use it. There is no documentation for the Forge. The only way to understand how it works is by reading the example provided in the repository. They assume you already know what you are doing since the logic is the same as using a standalone API. To be honest, if I hadn't spent time learning Vulkan, it would have been impossible to do anything with Forge. But since I was already familiar with how graphics APIs work, it was straightforward. And after a day or two of learning from the samples, I rendered yet another damn triangle. Yeah, it's all about triangles. And then I went again to make some more school projects for 3 months or so, because I was really running out of time before, you know. After finishing my projects, I continued searching for libraries to use for different systems in the engine. For Windows management, input handling and audio, I used SDL3. I chose Flex for the ACS, and for animations I will use Oz Animation. For physics I will use Box2D for 2D physics and Jolt for 3D physics. By the way, Jolt is the physics solution developed for Horizon, and it was open sourced later. For texture compression I will use DirectX Tex, primarily using PC7 compression. For profiling I will use Tracy, which is also open source. For loading 3D objects I will use SAMP, which supports almost every format out there. There are many other libraries I'm using that are more technical, but I won't bore you with all the details, because they are quite a lot. For most of the internal system, I rely on open source libraries to implement them. It will still be a respectable amount of work to integrate them and make them work together seamlessly, but of course it will be far less work compared to creating them from scratch. In fact, it would be impossible for me to even think about making an engine without these libraries. So I think I'm kind of lucky to have been born a bit late, I guess.
Lovely.
But one thing I need to do entirely from scratch is graphics and rendering. As I mentioned, Forge only abstracts low-level APIs and nothing else, so making something look cool on the screen while performing well, that's my job. And of course that's the most fun part. After all, the whole idea of making an engine in the first place is to learn graphics and rendering, so yay. I also spent a respectable amount of time just structuring the files, creating tons of core functions and systems, and making sure everything was cross-platform. After implementing SDL3 and hooking the window with Forge so it could render to it, we had a black window. But the most important thing was that we could make it red, and now we are sure we are rendering to the window correctly.
Nice.
And then I wanted to implement the rendering architecture, and oh my god, what a month that was. It wasn't a month of implementing anything, it was just a month of searching and experimenting. There are so many ways to render things in games in the industry standard way. And yeah, I was kinda overwhelmed, but how to explain this? It was like being in a restaurant where you want to order something but can't decide because everything looks delicious. I was reading about how Elden Ring renders its sword, for example, or how God of War does it, or listening talk about mesh list or whatever in Alan Wake 2, or how they rendered the clouds and the sky in Red Dead Redemption 2. Although that's not directly related to rendering architecture, that was my new entertainment. I was completely lost because, of course, watching or reading about how a AAA studio implements something is entirely different from trying to implement it yourself. I mean, what in the seven hells is this? God, I need to learn math. And speaking of math, this video is sponsored by Brilliant. None, I'm joking. So I had to implement a rendering architecture and I chose to go fully GPU driven, where the CPU has much less work to do on the rendering side of things. Pretty much everything gets moved to the GPU. You build the drawing commands on the GPU, you do culling on the GPU, simulation on the GPU, and of course, rendering on the GPU. This is possible thanks to something called compute shaders, where you can literally do any parallel work on the GPU, and it's like magic. It opens up a lot of new possibilities that are impossible to do on the CPU. Game engines, however, like Unity, tend to not use them heavily to stay compatible with low-end GPUs and older mobile devices. But for me, I guess screw that. I don't want to support mobile, and I guess there is a small fraction of people still using all the GPUs from like 2015 that do not support compute shaders. I have a GTX 1060 which is older than the universe, and it still works with almost all modern graphics features except for hardware ray tracing. So yeah, I'm going to go full GPU driven with bindless textures. Well, after 2 months of implementing this architecture, I rendered this.
What the fuck is this piece of shit?
I know it does not look exciting, but believe me, it is more than just rendering triangles here. Well, there is also squares, but that's not the point. The real idea here is that each unique shape represents a mesh. That mesh could be anything: a building, a rock, a character, you name it. Each color represents a texture assigned to a material. What makes this cool is that everything here is rendered with a single indirect draw call, even if the texture assigned to the material are different. As long as they share the same material, or to be more precise, the same shader, they will be rendered at once. If you are familiar with Unity's renderer, you know this isn't possible unless you implement it yourself. And honestly, I will implement it when I will use Unity, because the performance gains and the flexibility of this approach are totally worth it. Of course, there is a trade-off. You will sacrifice support for older hardware since many of the features required for GPU-driven rendering aren't supported on those devices. But as I said, those devices are very old, and your game probably wouldn't run efficiently on them anyway. After that, I implemented many systems unrelated to rendering. I added a referencing counting system, I moved the rendering to another thread, and I implemented the ability to add and remove components from an entity. This was straightforward thanks to the amazing Flex library. I also added transform propagation, so when you transform an object, all its children are affected as well. Additionally, I implemented native scripting, though hot reloading isn't available yet because it is tricky when you are using C++. And input handling, allowing you to do things like is key being pressed or is key released and that kind of stuff. I have added so many things that I've honestly forgotten some of them, but one notable addition is Premake as my build system. Along with that, I created a small program called Nano Vanguard, which acts as a launcher or a helper to build the source code, generate solution files, or create new projects. It's like a command line version of Unity Hub, if you will. I was getting sick of staring at the same bunch of triangles over and over again, so it was time to move on to 3D. I implemented a camera and added a lot of math, and trust me, I don't have the power or the energy to explain it. If you want, however, to learn how games project 3D worlds into the 2D screen, check out some of the resources I'll include in the description. They'll explain it in 1,000 times better than I ever could. After spending some time learning the math and implementing it, I finally rendered my first cube. And look at this. Beautiful, isn't it? To make it even better, I added the ability to rotate it. I created a script that inherits from iEntity behavior, and in the update function, you can do something like this to rotate the cube. And voila! Yeah. Scripting, baby.
Yeah, boy.
After that, I added the ability to load textures from PNG files and compress them into the PC7 format. You can't just send the PNG directly to the GPU. Well, technically you can, but you shouldn't, as it wastes a significant amount of performance. Textures need to be compressed into a block compression format before being sent to the GPU. If you have ever wondered why Unity is constantly complaining about the resolution of the texture must be divisible by 4, because it is a requirement for compression. And you should not ignore that warning, you should always try to compress your textures. After implementing texture support, the next thing I worked on was adding more math. Of course, this meant 2 days of debugging why it wasn't working, because I'm dumb, but in the end, we have a skybox. And then I got excited and started making this video. So here we are. Of course, a single cube isn't much to brag about, so I made 100 cubes. Then I thought, we are doing GPU-driven rendering, so why not 10,000? And it worked, and with more than 90 FPS. I'm sure it can still be optimized further because 10,000 objects is nothing for the GPU. The main bottleneck right now is the CPU, as it's processing 10,000 entities one by one. There is definitely room for improvement there. Nonetheless, I'm proud of this. It's already running nearly 30% faster than Unity, so that's something. And yeah, that's where I'm at. I think progress will move faster now that the core structure of the engine is complete, unless I need to add something critical. But next I plan to focus on adding real graphics, loading 3D models, animations, and similar features. That will be challenging of course, but it's the whole point why I'm doing this. In the meantime, I'll also be using Unity while continuing to work on my engine. I want to apply my newfound knowledge and see how it will be reflected in an engine like Unity. Will the rendering skills I gain from developing my own tech improve the games I create? That's the big question. And of course, the elephant in the room. So let's hope Unity doesn't pull another surprise out of nowhere. But honestly, I doubt they'll do anything like that for years to come. Because if they do, it will be a game over for them. It will be their sayonara. Still, who knows, maybe I'm wrong. Finger crossed they will focus on making the engine great and avoid screwing things up for both themselves and us again. Also, I'm planning to start giving Blender more time because, that art thing is annoying me, to be honest. I need to start making art. So yeah, I guess that's it. Don't forget, by the way, to join us on Discord so we can hang there. And I guess that is everything, ladies and gentlemen. So, see you soon.